Welcome to Brain Vision.
So the question wants us to describe what happens to atomic radius as we move across the period. And also has to move down a column or group on the periodic table for the transition element. So basically, the transition elements are the D block element. So for the transition element, the atomic radius increases down a column. So atomic radius increases. So down a column, atomic radius increases. And it increases because you have addition of extra shells as you go from the top to the bottom. So you are increasing the principal quantum number, which leads to an increase in the shell number, the number of shells that you have in that atom, and also leads to an increase in the size of the atom that leads to a corresponding increase in the atomic radius. But across the period, when you go across the period, the radius remains roughly the same. So radius remains roughly the same. And that is going across a period. This is because the number of electrons in the outermost s orbiter is almost constant. Therefore, the added electron goes into the d orbiter of the highest energy. So the number of outermost electrons remain constant, and they experience a roughly effective nuclear charge, and that's almost the same shielding. So it's just like a rough estimate. Like we all know that when we move from left to right across a period, the size is supposed to decrease, but for the D block it's roughly the same because of this explained effective nuclear charge that remain roughly constant when you're moving across the period for the transition element or the transition method.